Hi everyone and welcome back to another video. This time I'll walk you through the process of connecting to a SQL Server database using a set of classes available for us in C#. But before we start coding, I should mention that installing Microsoft SQL Server and creating an actual database with tables and data is topic for a different video. For now, we will focus on a sample database that I have created in my local SQL Server instance. As you can see from my screen, I have created a database called Contacts Manager with a table called Contacts, which I have repopulated with some data. For this example, and in order to keep things simple, my table only stores first name, last name, and email addresses for each of my contacts. With this setup ready, we can now jump in the code. So go ahead and open Visual Studio, create a new console application project, and let's begin. C# offers many classes to solve different problems. The ones that we will use in this example are contained in the System.Data.SQLClient namespace. You can think of a namespace as a toolbox that contains classes that you can reuse in your programs. So, the first step will be importing these classes into our program by adding one line of code at the top of our program.cs file. The syntax is the keyword using and the namespace. Now we can use these classes anywhere in this document. We'll focus particularly on three classes. SQLConnection, which allows you to open a connection to a database given a specific connection string. SQLCommand, which allows you to provide a command to run on the database server. And SQLDataReader, which allows you to store data coming in from the executeReader method of the SQLCommand class. The common database operations that you can perform using these classes are insert, select, update, and delete. But before we can create a connection, we need to get a connection string. This is a specially formatted string that contains the necessary information to connect to a database server. That is, server name or address, database name, user ID, and password. Connection strings come in different flavors depending on the database technology you are using. But if you want to have a reference, you can go to connectionstrings.com, look for SQL Server, and grab the standard security format. This is the format I will use with the information needed to connect to my SQL Server. It is always a good idea to save these connection strings values in the app config file of your application, but we'll store it in the string variable for simplicity. Step 1 is creating an instance of the SQLConnection class, and it's a best practice to wrap it in a using block with the following syntax. Using, parentheses, my object instance, open close curly brackets. At this point, you also need to provide the connection string for the object to know where to connect. You can do that in the constructor of the class, passing your variable inside the parentheses, or on a different line of code using the connection string attribute of the SQLConnection object. I'll pass this value in the constructor method. Now, the benefit of this syntax is that your connection will be closed and disposed of once the execution passes the last close curly brackets. This will prevent your application from leaving connections open that can make other applications fail in establishing a connection to the database server. To finish setting this up and open the actual connection, let's call the open method of the SQLConnection object. Now, step 2 is providing the command we want to execute. We'll do this inside the SQLConnection using block after we have opened the connection by creating an instance of the SQLCommand class and wrapping it in another using block. There are two things that my command needs: the connection object to use and the actual command as text. We can set them up in the constructor or separately. I'll do this separately this time by adding 2 lines of code and using the connection and command text attributes of my SQL command object. As you can see, the command text attribute can store any type of command: select, insert, update, and delete, and even more complicated ones. For now, I'm selecting everything from my table. Finally, step 3 is using a SQLDataReader object to receive the data from the results of my command. For that, I'll create an instance of the SQLDataReader class. But instead of creating a new object, I will be storing the results of the executeReader method of my command in it. At this point, my SQLDataReader object is full of data. Now I need to read it out. Note that the way that this object accesses the data is sequential, which means one record at a time from top to bottom. If I have 100 results, I will need a loop to go through all of them. So let's do this using a while loop and the read method of my dataReader object, which returns true if there is a record to read in the next position and false if there aren't any. In every iteration, you'll be able to access the information for that one record as if it was an array, using the column name as opposed to an index number. If you remember from my table in the beginning of this video, I have the first name and last name columns, and this is the data I want to output. So let's store these values in 2 different string variables. It is important to mention that the dataReader object actually returns a collection of objects. Since we know the values that we are retrieving are text, we have to convert them to string by using the toString method of that object. Now that we have these values, we can output them using a simple console.writeLine statement. It is also important to remember to always close your data reader object after you are done with it. Let's also add a console.readKey instruction at the end of my program so that the console window remains open. Now let's run it so we can test it. As you can see, all the information has been retrieved and printed on the console. This will be all for now. I hope this video has been useful, and I will see you in the next time. Thanks for watching. Bye now.